Wait, are you talking about a time machine?
You know the rules of time jumps, right?
Time travel, a concept that has been explored since the early 1900s.
I have no idea, but we're talking about time travel here. Either it's all a joke or none of it is.
Have you ever wished you could go back and change a past mistake? Or maybe get a sneak peek into the future? The idea of time travel has captivated us for centuries, from classic novels to blockbuster movies. But is it just science fiction? Or could it one day become science fact? Today, we're taking a deep dive into the fascinating, mind-bending science of time travel. Let's peel back the layers of reality and see what's theoretically possible. First, let's talk about what time actually is. We often think of it as a constant, universal clock ticking away at the same rate for everyone. But one of the most brilliant minds in history, Albert Einstein, completely shattered that idea. His theory of relativity revealed that time is not absolute. Instead, it's relative and flexible, intertwined with space in a four-dimensional fabric called space-time. Imagine space-time as a giant trampoline. Massive objects, like planets and stars, create dips or curves in this fabric. This curvature is what we experience as gravity. So, how does this relate to time travel? Einstein's theory of special relativity tells us that the faster you move through space, the slower you move through time relative to a stationary observer. This isn't just a wild idea. It's a proven phenomenon called time dilation. For example, astronauts on the International Space Station are traveling at incredible speeds, about 17,500 miles per hour. Because of this, they age just a tiny fraction of a second slower than we do here on Earth. If we could build a spaceship capable of traveling close to the speed of light, this effect would become much more dramatic. Imagine you take a trip on this spaceship for what feels like 5 years to you. When you return to Earth, you might find that 50 years have passed. Your friends and family would be much older, while you would have only aged 5 years. In a very real sense, you would have traveled into the future. This isn't a paradox. It's a direct consequence of the laws of physics as we understand them. The technology to achieve this is far beyond our current capabilities, but the science behind it is solid. So, traveling to the future, it seems theoretically possible, if incredibly difficult. But what about the past? This is where things get truly complicated and enter the realm of mind-bending paradoxes. To travel backward in time, we would need to find a way to manipulate space-time in a much more extreme way. One theoretical concept that could allow for this is a wormhole, also known as an Einstein-Rosen bridge. Picture our space-time trampoline again. A wormhole would be like punching a hole through the fabric and connecting it to another point, creating a shortcut through space and time. If you could stabilize a wormhole, you could potentially enter one end and emerge at a different point in space-time, possibly in the past. It sounds like a perfect solution, right? Well, not quite. The physics required to create and maintain a stable, traversable wormhole is mind-boggling. It would likely require something called exotic matter, a mysterious substance with negative mass and energy. We've never observed exotic matter, and we have no idea if it can even exist. So, while wormholes are a popular staple in science fiction, they remain purely theoretical for now. Another idea comes from the mathematician Kurt Gödel, who discovered a solution to Einstein's equations that describe the rotating universe. In this universe, if you traveled far enough, you could end up back where you started, but at an earlier time. However, our observations suggest that the universe is expanding, not rotating. So this model probably doesn't describe our reality. Even if we could find a way to travel to the past, we'd immediately run into some serious logical problems. The most famous of which is the grandfather paradox. Imagine you travel back in time and prevent your grandparents from ever meeting. If they never meet, one of your parents is never born, which means you are never born. But if you were never born, how could you have gone back in time to prevent them from meeting in the first place? It creates an inescapable logical loop where your action erases the very possibility of you taking that action. It's a contradiction that seems to make travel to the past impossible. To resolve this, physicists have proposed a few intriguing ideas. One is the Novikov self-consistency principle. This principle suggests that the laws of physics forbid any action that would create a paradox. In other words, you could travel to the past, but you would be physically unable to change it. Any action you take would, in fact, be part of the events that were always meant to happen. If you went back to save someone from an accident, you might find that your very attempt to save them is what caused the accident in the first place. History would be immutable, and your presence in the past would simply be another thread in a pre-written tapestry. In this view, free will in the past is an illusion. Another, perhaps more exciting, possibility is the many worlds interpretation of quantum mechanics. This theory proposes that every time a quantum measurement is made, the universe splits into multiple parallel universes, one for each possible outcome. If this is true, then when you travel to the past and change something, you don't actually alter your own history. Instead, you create a new, branching timeline. In this new universe, your grandparents don't meet, and a version of you is never born. But in your original universe, everything remains unchanged, and you can safely return to the timeline you came from. This neatly resolves the grandfather paradox by creating a separate reality where the contradiction doesn't affect your own existence. This idea opens up a multiverse of possibilities, where every choice creates a new world. Let's also consider the information paradox, also known as the Bootstrap Paradox. Imagine a time traveler goes back to the past and gives a young Shakespeare a book containing all of his future plays. Shakespeare then copies them and becomes the famous playwright we know today. The question is, where did the plays originally come from? Shakespeare didn't write them, he copied them. But the time traveler didn't write them either. They got them from a book that was originally written by Shakespeare. The information the plays themselves seems to exist in a closed loop with no clear origin. It was simply created out of nowhere. This paradox challenges our fundamental understanding of causality and the flow of information. It suggests that if time travel is possible, our universe might contain information loops that exist without a point of creation. So, where does that leave us? Traveling to the future seems to be a matter of engineering, albeit on a scale we can barely imagine. We would need to harness immense amounts of energy to propel a spacecraft to near light speeds. But the underlying physics, thanks to Einstein, is well established. Travel to the past, however, remains a deep and profound mystery. It would require us to bend the fabric of space-time in ways that might need undiscovered forms of matter and energy, and it forces us to confront paradoxes that shake the very foundations of logic and causality. Whether it is through self-consistent loops where the past is unchangeable, or through the creation of new parallel universes, the theoretical landscape of time travel is as challenging as it is exciting. The quest to understand it pushes the boundaries of our knowledge about the cosmos and our place within it. Perhaps one day, our descendants will look back at this era as the dawn of temporal exploration. Or maybe The past is destined to remain forever out of reach. A locked room in the house of space-time. For now, the only time machine we have is our own imagination. But the science it inspires continues to be one of the most thrilling journeys of all. Thanks for joining me on this mind-bending adventure through time. If you enjoyed this, don't forget to like, subscribe, and hit that notification bell for more deep dives into the mysteries of science. See you in the next one.